Hi, my name is David Healy and I'm the technical team lead of the Jefferson Journey Planner product. Welcome to the first of a series of videos designed to provide an introduction to the Jefferson Journey Planner API. The Jefferson Journey Planner API, or JJP, is a transit API that provides access to public transport data for over 30 cities worldwide. For each city, it provides functions such as A to B journey planning, nearby transit stop lookup, and stop timetable responses. A full list of features and datasets is available on the JJP website. In today's session, I'm going to dive into the API and run through some examples and showing you how easy it is to add transit data into your application. First up though, before you start, you'll need to register for an API key. Once you've got your API key, you'll need to embed this into every query you send to the API so that you can be allowed access. To register, simply head to www.jefferson.com/journey planner. On this site you'll find a sign up page. You'll also find links to our documentation, which include an overview of the interface for our REST and SOAP protocols, and also some sample clients written in C#, Java, and Python. So now I'm going to dive into the API. In today's session, I'm going to go through how to find out what datasets are available in JJP, and then we're going to dive into doing some journey plans within those datasets. To do this, I'm going to be using our REST protocol, and I'm going to be doing it via Fiddler. For those of you who aren't familiar with Fiddler, it's a web debugger proxy for Windows. It provides a simple interface which you can use to execute REST requests and then look at the raw responses. In the request builder section here, I'll be entering in our REST URLs and building up our query strings. I'll then be looking at the responses and the XML returned. It should be noted that any of the URLs which I create today can also be pasted directly into a browser, and you should get back the XML or JSON that you would expect. So, before we start, all of our REST requests are executed against a base URL, which I've pasted in there. This is defined in our REST overview document, and in our REST documentation, all of the template URLs are specified relative to this base URL. The first query I'm going to demonstrate today is the datasets query, which will return a full list of datasets supported by JJP. To do this, we specify that we'd like to see datasets, and in the query string we specify an API key and the format with which we would like the response in. In this case, I'm going to use XML, but you could also specify JSON. As described, the response returns a list of datasets which are available for use. For each dataset, an ID is returned, which should be used to every query for that dataset. A name is returned, and then we also return a boundary polyline which specifies the top left geocoordinate and the bottom right geocoordinate for that dataset. We also specify a start and end date, which indicate the first and last dates on which trips run within the dataset. At this point, I'm going to jump back to the request builder and point out that JJP supports gzip encoding. This can be used to compress the sizes of the responses. So if we add an accept encoding parameter of gzip into the HTTP header and execute the query again, we now see that the response size comes back and is smaller. This is only a small response, so the difference isn't massive, but for some of the responses, which can be up to 2 or 3 megabytes, the difference is quite big. Up to 20% compression is achieved with gzip. So now that you know what datasets are available within JJP, I'm now going to execute a reference data request. These reference data requests are used to obtain sets of data which are hosted by JJP. In particular, we provide information on the transit stops within a dataset, the transit modes supported by that dataset, and the service providers which operate within that dataset. In this case, we're going to get a list of transit stops available. So to do this, I specify the dataset I'd like to find out about, which is cans. I specify that I like reference data and that I want transit stops. In our query string, we once again add in our API key and the format we'd like the response in. Executing this response now returns a document that has every transit stop within the dataset. For each transit stop, we provide a stop UID which uniquely identifies that stop, a description which is the name of that transit stop, and finally the position of that transit stop, which is a geocoordinate marking where it is. This data could be used to simply map every stop within a dataset on a map. Alternatively, you could also use this for things like an autocomplete box, so that when a user is typing in a stop name, you can provide them suggestions for that stop. So now we have an idea of what datasets are available, and we also have an idea of getting reference data from those datasets. I'm now going to show you how to do a journey plan. In this case, we're going to do the journey plan in Perth. So I'm going to go back to my REST URL, back to datasets, and specify that I want to use the Perth dataset. Rather than reference data, this time we want to do a journey plan. Now, there are more query parameters for the journey plan because there are more things you can configure. Again though, we'll start with the API key, and now I'm going to add in a from location. In this case, I'm using a geocoordinate. Alternatively, if you'd previously done a reference data request, you could specify the stop UID so that you can identify a specific stop you want to depart from. I'm now going to specify the to location, which we'd like to travel to, again using a geocoordinate. Next, I'm going to specify the date and time which we'd like to depart at. The format of this string is available in the documentation. I'm going to specify my time mode, which in this case is leave after. This indicates that I want to see all journeys departing after the time specified. Alternatively, I could specify arrive by to show all journeys arriving by that time. Next, I'm going to specify that I'd like some mapping data returned. This will result in JJP returning a list of geocoordinates that describe the path taken by all your journeys. And finally, I'm going to specify the format, which is again XML. So I've executed the query, and we'll now look at the raw response. The documentation provides a complete overview of every object returned in the response, but I'm just going to point out the important ones now. First of all, we return the original request which is sent in, unmodified. The most important thing really though in this response is the journeys. This is a list of journey objects that defines the journeys which match the parameters specified in the URL. By default, we will return 3 journey options. Alternatively, you can actually specify how many you want. Within each journey, we return a depart and arrive time for that journey, and we return the origin and location. These origins and locations are actually IDs into an index, work as an index into the list of locations which is appended at the end of the response. We also return the overall duration of the journey, in this case 83 minutes. Into the detail of the journey, we then have a list of legs. Each leg may be of one of 3 types. A walk leg, indicating that you have to walk through the street network, a transfer leg, which indicates that you transfer between 2 stops, or a trip leg, which indicates you are undertaking a trip on a public transport service. For the walk legs, we again return an origin and destination location. We also return the distance of the walk and a polyline which describes the path taken. This is in the form of a semicolon delimited list of geocoordinates. For a trip leg, we return more detailed information about the transit service which you are using. Again, we have the origin and location ID, we have the duration, we also have a depart and arrive time for that trip at the stops you are boarding and alighting. We have the mode of the trip, and then we also have information about the route code, and the head sign. And finally, we also include the full polyline for that trip, which is again a semicolon delimited list of geo-coordinates. This provides a basic overview of the elements returned in a JJP journey planning response. Using these elements, you should be able to display to your user all the information required for them to actually undertake that public transport journey plan. So there you have it. That's a very brief intro into JJP. Hopefully using this service, you can build a fully featured transit application, or alternatively, you can add useful transit information into an existing application. I hope this has been informative. If you have any questions or any feedback, please visit our website and let us know what you think.